Hello, welcome back. Today we are going to focus on Unit 2, determining solutions to equations. And then our essential question is, what are the different types of special cases when solving equations? So let's first take a look at what I mean by solutions to equations. There are three different types of solutions. So everything we've looked at so far is one solution. So that means there's only one number will work to make the equation true. Then we have no solution. It means no number will work to make the equation true. So an example we're going to look at is we'd have the same coefficients, but different constants. Okay, and then the last one is all real numbers or infinitely many solutions. Okay, so that means any number will work to make the equation true. So if we're looking at this means we're going to have the same coefficients and the same constants. Okay, so everything in the equation will be the same. It might be in a different order, but remember the commutative property tells us that we can switch those around. Okay, so let's take a look at some examples. You're going to notice I've set these up so you can, what should be written in your notebook is what I have here, okay? So it should make it a little bit easier for you. All right, so just like when we're solving equations, we have to follow our steps. Do I need to distribute? Yes, I need to distribute this 1/4 to everything inside the parentheses. And remember, we just divide. So 8 divided by 4 is 2x. 4 divided by 4 is 1. And over here, I have 2x minus 4. So our goal right now is to actually recognize that this is going to be a no solution. Let's determine why. So let's actually finish solving this. So I'm going to subtract 2x on both sides. Well, 2x minus 2x is 0, so I have 1 equals -4. That's not a true statement. 1 does not equal -4. So this is what we call a no solution. What we want to be able to recognize is that this 1/4 8x plus 4 equals 2x minus 4. We want to recognize that when I simplified this, and I got 2x plus 1 equals 2x minus 4. We notice that we have the same coefficients. So the variables and the coefficients are the exact same. But we have different constants. Okay, that makes it a no solution. But if you continue to solve the problem and you get something that's not true, like 1 equals -4, then you also know you get a no solution. So let's try a different problem. Okay, I need to distribute. We're always going to need to simplify the problems first. Distribute and combine like terms. So I get 14x minus 7 equals 1 plus 14x minus 8. Now I need to check, do I need to combine like terms? Yes. On the right, I got 1 and -8. I need to put those together. So I end up with 14x minus 7 equals 14x minus 7. So what we should be able to recognize here is that our coefficients are the same and our constants are the same. So this is infinitely many solutions. But let's take a look at why. So if I were to finish solving this and I subtracted 14x on both sides, I end up with -7 equals -7. That's a true statement. So we say this is infinitely many solutions, IMS. Okay, or we would say all real numbers. Okay, both are correct. Again, we just want to recognize those constants and coefficients. All right, so let's look at another example. Notice I'm writing the page numbers in here. You should be doing that too. It really helps to find the right pages. Okay, so if I'm going to solve this, I need to distribute first. So I get 13 plus 2x minus 12 equals 4x minus 7. Okay, now I have to combine some like terms. I got to put 13 and -12 together. So I'm going to get 2x plus 1 equals 4x minus 7. If nothing is the same on each side of the equation, you need to solve it. That means that that's going to have an actual answer. So we're going to keep solving this. So I'm going to subtract 2x on both sides. Okay, now I'm going to add 7. So x is 4. Okay, this is one solution. Okay, let's take a look at our next one. I don't need to distribute this time, but I do need to combine like terms. So I have like terms, 12 and -8. And on the other side, I have like terms, 2x and 2x. So let's put these together. So I'm going to get 4x plus 4. And then I'm going to get 4x plus 3. So the minute I see the same coefficients with the variable, I know it's either going to be infinitely many solutions or no solutions. So once I find that, I'm going to go ahead and look at the constants. Well, my constants are different. So this would be no solution. I don't need to go any further. But again, if you're having trouble seeing that, let's actually go one step further and subtract that 4x. 4 minus 4 is 0, so I end up with 4 equals 3. Okay, that's not a true statement. That's not true. So it's no solution. All right. Let's take a look at this next one. I need to distribute. So I'm going to distribute a half. So I'm just going to divide. 6 divided by 2 is 3, so I get 3x. 8 divided by 2 is 4. Over here, I need to combine like terms. I'm going to start doing things in one step. So that's going to give me 3x plus 4. Oh, what are you noticing? Hopefully you recognize that these are the same. I have the same coefficients and the same constants. Okay, so this one is infinitely many solutions, or all real numbers. why don't you go ahead and pause this video and try problem 6. Hopefully you've paused the video and you've worked this out. So let's take a look. So I need to distribute first. So 3x plus 3, got 4x and 7x plus 5. Okay, I need to combine like terms, 3x and 4x. So that's going to give me 7x plus 3 equals 7x plus 5. So already I know that my coefficients and variables are the same. I see my constants are different, so this is a no solution. Okay, go ahead and pause the video again and try problem 7. Hopefully you've paused the video and worked this out, so let's check. We got to distribute first. And on this side, I need to combine like terms. So I'm going to get 5x plus 8. Over here, I'm going to get 5x plus 15 minus 7. I've got to combine some more like terms. Not doing anything with this side right now. And then 15 minus 7 is 8. Oh, now I take a look. I've got the same coefficients and the same constants. So this is infinitely many solutions, or all real numbers. Okay, go ahead and pause the video one more time and solve this last one. All right, I need to distribute the 4 and this 6. So I end up with 16x plus 12. And then I end up with 6x plus 12 plus 10x. Now I need to combine like terms on the right. So I've got 6x and 10x. So 16x plus 12x equals 16x plus 12x. Or I'm sorry, 12, not x. Now, I notice my coefficients and variables are the same. I also notice 12 and 12 are the same. So again, this is infinitely many solutions. Okay, at this time, this lesson is done. You may move on to your assignment for today.